Good morning, professors, and welcome to an exciting new experience with the Wacebo Science Bus. In this particular experience, we will explore how to effectively utilize the digital multimeter to accurately measure voltage and resistance values. The experience is appropriate for high school students, and you will require the electricity kit to successfully conduct it. Let's proceed by accurately measuring the resistance values. Initially, we very carefully insert the red cable originating from the banana connector side into the specifically designated port with the volt-ohm symbol, and the black cable into the port labeled as COM. Let us take a widely acknowledged resistor from the circuit and meticulously attach the alligator clips to the terminals of the resistor. At this particular moment, it is necessary for us to adjust the selector to the ohm setting and choose the appropriate range. The range signifies the utmost value the instrument is capable of measuring. Therefore, if we have opted for a 100 ohm resistor, we must set the selector to 200 ohm. Now, let us proceed to activate the multimeter and carefully observe the displayed value on the screen. It accurately indicates a measurement of 100 ohms. After the measurement is thoroughly completed, we deactivate the multimeter and proceed to select an alternative resistor. At this particular moment, it is necessary to measure a 470 ohm resistor. We carefully connect the clips to the respective ends of the resistor. Subsequently, we proceed by activating the multimeter and attentively observe the overload notation that appears on the display. This indicates that the instrument is currently beyond its measurable range. Then we should adjust the range setting to 2000 ohms. By doing so, we can observe a measurement value of approximately 467 ohms. Approximately close to the nominal value of 470 ohms. Let's continue by substituting the resistor, after which we switch off the multimeter and carefully disconnect the terminals. Now let's select a 220 ohm resistor. Then we securely fasten the clips to the terminals of the resistor. In this particular instance, there will not be any necessity to alter the range, and we observe that the multimeter displays a measurement of 219 ohms, which is extremely close to the nominal value of 220 ohms. We shall proceed to replicate the identical procedure for a resistor whose value is not known. In the event that we encounter an overload indication on the display, we will adjust and select a different range. In this particular instance, we have configured a range of 2000 ohms. Consequently, the multimeter displays the exact resistance measurement, which is extremely close to the nominal value of 1000 ohms. Now, let us carefully observe the detailed procedure for effectively utilizing the multimeter in order to accurately measure electrical voltage. We consistently maintain the red cable within the port marked with the volt-ohm symbols, while the black cable is consistently placed in the COM port. Now, let's take a battery. This particular one is 9V. If you opt for an AA battery, it is more advisable to utilize the probe cables. At this point, we will proceed to adjust the selector to the section designated for measuring volts. We then attach the clamp of the black cable securely to the negative terminal of the battery, while the red clamp is connected to the positive terminal, just like this. We establish a range of 20 volts and activate the multimeter, observing that it displays a voltage reading of precisely 7.19 volts. This measurement is accurate because the battery has been used, leading to a battery voltage that is lower than 9 volts. The experiment can be conducted once more with different types of batteries and various levels of charge. Professors, thanks a lot. See you at the next experiment.